Hi there, Mr. Arnold here for Hegarty Maths, and this is a video tutorial on completing the square, and this is aimed at the core maths modules. Okay, so what is completing the square? Well, it's a technique that allows us to write a quadratic in the form a times x plus b all squared plus c. And that's where a, b and c are just some numbers that we have. So for example, in this one here, a would be 1, it's outside the bracket, b would be 3 and c would be 0. I'll come back to that in a moment. But suppose I was to expand this out, we would get x squared plus 6x plus 9. I can do the same here and we get x squared minus 10x plus 25, and we get x squared plus 2px plus p squared. You might be wondering how I could do that so quickly. I'll just tell you the little trick. What I do is I square the first term, I do x times 3 and then I double it to get the 6x, and then I square the last term. That gives me the 9. And we can do the same for the other two. Now something else you might have noticed, and it's a really important feature, is that this number here, the plus 3, is half of this. And we have the same happening here. Negative 5 is half of negative 10, and p is half of 2p. And that's an important feature that we're going to use to help complete the square in a moment. So suppose we have these two expressions here, these two quadratic expressions. Now if I look at the first one, x squared plus 10x plus 25, I could factorize this. If I was to factorize it, I would get x plus 5 times x plus 5. So two numbers that multiply to make 25 but add to make 10, 5 and 5, which is simply x plus 5 all squared. So this expression here is what we call a perfect square, and these guys up here are all perfect squares. Now the expression on the right hand side is not a perfect square, so we're going to have to make some adjustment. So if we remember, when it was expanded out, the coefficient in front of the x, if we halve that, that's what was in the brackets. So I'm going to try and do that now. So if I write x down first, and this is going to be positive, because this is positive. You'll notice here that's positive, that's positive. When that was negative, that was negative. And also the number that went in the bracket here was half of this number here. So let's half the 10 and we get 5. And then we put a squared sign. Now if I was to expand this out, I would get x squared plus 10x plus 25. Let's get rid of that 25. Take away that 25, and then I can account for this 29 on the end to make sure I've done it correctly. Tidying up, we get x plus 5 all squared plus 4. Now let's check and make sure that this is done correctly. So I'm going to expand this out. We get x squared plus 10x, so I'm expanding out the brackets, plus 25, and then we've got the 4 on the end, plus 4, and when we tidy that up we get x squared plus 10x plus 29. So this was what we were trying to do, and we can see that when I expanded it out and checked, we had what we began with. So this is written in the form a times x plus b all squared plus c. And we can see that a would be 1, b would be 5, and c would be 4. Let's try a few more. Okay, so first example we have here, we've got x squared plus 4x. So what I'm going to do is I'm going to open a pair of brackets because I need this x plus b squared. So x must go first. This is positive, so this will be positive. And I need to half this number here, which gives me 2, and square it. Now if I was to expand this out, I'm going to end up with a plus 4 at the end. So squaring 2, we get 4. Let's get rid of that to make sure that we end up with just x squared plus 4x. I'm going to check my answer. So I'm going to change the green just to show the check. So we get x squared plus 4x plus 4. Take away that 4, and that leaves us with x squared plus 4x. So the part in blue was exactly what we were looking for. The green part is just a check. So that's the first one done. Let's look at the second one. We've got 3x squared minus 12x. Now in all the previous examples, the number or the coefficient in front of x squared was always 1. This time it's not so. So I need to account for that. What I'm going to do is I'm going to factor out a 3 here. So factor out a 3, and that would leave me with x squared minus 4x. What I can do now is I can complete the square for this part here. So I'll underline it in red. So I'm going to complete the square for this, all the while leaving the 3 outside, and we can worry about that a little bit later. So let's complete the square for this. Open a pair of brackets, x goes in. That's negative, so this must be negative, and half that number there, we get 2, and square that. If I was to expand this out, I'm going to end up with plus 4 at the end. I don't want that, so let's take that 4 away. Okay, last part now. What I need to do is expand this 3 into the expression. So we get 3, open the brackets, x minus 2 to be squared minus 12. Okay, and that's now written in the form a times x plus b plus c. A is 3, b is negative 2, and c is negative 12. And if you want to check this, expand the brackets out, multiply it by 3, and then take away the 12. And you should find that we end up right back where we started. Excuse me. Okay, example 3. So we've got 3x squared minus 5x. Again, we've got a coefficient of x squared that's not 1. So I'm going to account for that by factoring out a 3. So factor out a 3, open the brackets. X squared would have to go here. And in order to get negative 5x, what I'd have to have is negative 5 over 3x. If I was to expand this back out, we'd end up back here. Okay, now what I can do is I can complete the square for this part. So, leave the 3 outside. I'm going to leave the 3 in the brackets in blue and then deal with the part underlined in red. So 3, open a pair of brackets, and let's complete the square for this expression. So open some brackets, x will go first. This is negative, so this must be negative. I need to half this number here, and half of 5 over 3 is 5 over 6. Close the brackets, square outside, and now let's adjust. So if I was to expand this bracket out now, I'd end up with a positive 25 over 36. I don't want that, so I'm going to take that away. I don't want that 25 over 36. So that's now gone. And then the final part is just to expand this 3 across the whole bracket. So we do 3 times this expression here, which will give us 3 times x minus 5 over 6 to be squared, and then 3 times this expression here is going to give me negative 25 over, and then 3 into 36 goes 12 times. And that's the job done. A times x plus b all squared plus c. Okay, example 4. X squared plus 6x plus 11. Now in all the examples you might have noticed that I've always been just dealing with the the x squared and the part with the x. So I'm going to do exactly the same way. Let's just worry about this for now, and I can add in that 11 later. So let's complete the square. For x squared plus 6x, we'll get x squared. We won't get x squared, we'll get x. Let's try that again. So open a pair of brackets, x, half this number here, which is 3, close the brackets, stick a squared sign outside. Think about it now, when I expand this out, I'm going to end up with a positive 9. So I'm going to take that 9 away, and then we still have this 11 at the end. Now let's tidy it up, and we get x plus 3 all squared plus 2. We'll do a quick check. Let's expand this out. We get x squared plus 6x plus 9, and then we have the 2 on the end, and when I tidy that up, you should see we get x squared plus 6x plus 11. So the blue part is the answer here. Okay, example 5. Getting a little bit trickier now. Once again, just worry about the x squared part and the 4x part. We can deal with the 3 a little bit later. So, the first thing is I've got a 2 in front of the x squared, so I'm going to factor that out. And that leaves me with x squared plus 2x. And then we still have the 3 at the end. Now the next thing I need to do is complete the square for this part underlined in red. So again, we leave the 2 outside, open some brackets, and we've got the 3 as well at the end. We'll deal with that in a moment. Let's complete the square here. Open some brackets, we get x. This is positive, so this must be positive. Half the number here, we get 1. Close the brackets, square outside, and then make an adjustment. When I expand this out, I'm going to end up with a plus 1 at the end. I don't want that, so let's take it away. Next thing to do is to expand this bracket here. I'll underline it in green just to make it clear. So I'm expanding the 2 into this bracket, and we get 2 times x plus 1 to be squared minus 2, and then add on that 3 at the end, which we had here. Don't forget about that. And then the final part is just to tidy this up at the end. 2 brackets x plus 1 all squared plus 1. And if you want, you can check your answer by expanding, multiply by 2, and then add on the 1, and you should see that we get back to here. Okay, last example for this part, the hardest one of the bunch. We've got 4 minus 2x minus 3x squared. So it looks quite tricky. First thing to do here is let's write it in the form that we're used to. So with the x squared first. So I'm going to rewrite it as minus 3x squared minus 2x plus 4. So that's step 1. Next thing we're going to do is start to complete the square on this part. Now I can't do it just yet because I've got a negative 3 in front of the x squared. We're always used to having 1 in front of x squared before we complete the square, so let's modify for that by factoring out that 3. Factor out negative 3, open some brackets, x squared, and when I factor out negative 3 from this, we get plus 2 over 3x. Close that bracket, and then we still have the 4 at the end. Now let's just double check here. Negative 3 times x squared is negative 3x squared. Negative 3 times positive 2 over 3x will give me minus 2x, or negative 2x if you will. Okay, so now what I can do is I can complete the square for this part underlined in red. And like before, I'm going to leave the negative 3 outside in some brackets and the 4 at the end, and then we can take account of those later. So open some brackets, leave yourself some space. We've got the 4 at the end. Okay, let's complete the square. So we open a pair of brackets, we put in an x. This is positive, so this must be positive. I need to half this number here. Half of 2 over 3 is 2 over 6. So 2/6 is the same as 1/3. And that's squared. Now when I expand this out, I'm going to end up with plus 1 over 9 at the end, which I don't want, so let's get rid of that. Fantastic. Okay, next part. Expand this -3 across the bracket. So I'm expanding the -3 across this bracket here, and we get -3 times x plus 1 over 3 all squared, and -3 times -1 over 9 is going to be positive 1 over 3. And then we have the 4 at the end. So let's add that on. And then the last part is just gather this together, and we get -3 times x plus 1 over 3 all squared plus, and let's think about this, if I made this into thirds we would get 12 over 3, so we get 13 over 3. Now, for those of you that don't believe me that this is the same as what we began with, I'm actually going to expand this out. So let's do a check on the last one. We get, let's see, -3 times, and squaring this, x squared. X times 1/3 is 1/3 x. And then we're going to have another one. Let's double it, so plus 2 over 3x, and then square the last term, 1 over 9. And we have the 13 over 3 at the end. Expand in this -3, so we get -3x minus 2x minus 1 over 3, and that's plus 13 over 3 at the end, which gives us -3x squared minus 2x plus 12 over 3, and look at that, absolutely fantastic, minus 3x squared, or -3x squared if you will, plus 4. And you can see that this is exactly what we started with up here. Okay, so that's how we complete the square. Now let's see one of its really powerful uses, and we can use it to solve quadratic equations. In fact, it's actually the basis on which the quadratic formula, which you may have seen, comes from. Okay, so if I was to solve this equation using completing the square, first step is obviously to complete the square. So let's worry about this for now. So open up some brackets. We have x, not x squared. We have x in the bracket. This is negative, so this must be negative. That's a 4. So this, we got to half it, make it 2, and then square outside. Make the adjustment. When I expand this, I'm going to end up with positive 4 at the end. Squaring -2 gives me positive 4, so let's get rid of that. And then we have the 2. So the 2 comes in here. And then finally just tidy it up. So we get x minus 2 to be squared minus 2. I almost forgot, that's equal to 0, and that's equal to 0. So the next stage is to solve this. So I'm going to add 2 to both sides. So we get x minus 2 all squared equals 2. And then the next stage is to take the square root of both sides. We get x minus 2 equals the square root of 2. Now remember, when we take the square root of this, we actually end up with both a positive and a negative answer. And then finally, we need to split it. In general, quadratics tend to have 2 solutions. Most of the time anyway, not always. This one has 2 solutions. So we'll have x equals 2. I'm adding 2 to both sides. So 2 plus root 2. Or x equals 2 minus root 2. That's the first one done. Okay, let's look at example 2. We've got x squared minus 2x equals 11. So what I can do here is I can complete the square on this part. So open some brackets. We're going to have an x. This is negative, so this must be negative. Half this coefficient, we get 1. Open some brackets and square. And then make an adjustment. When I square this out, we'll end up with plus 1 at the end. So let's take away 1. And that's equal to 11. Next stage, I'm going to add 1 to both sides. So we get x minus 1 squared equals 11 plus 1 is 12. Then we're going to take the square root of both sides. And we get x minus 1. X minus 1 equals square root of 12. Do remember that's plus or minus 12. Now we can put this in, this is in surd form, so we can actually change this a little bit. You might remember from the video on surds that the square root of 12 is the same as 2 root 3. So we get x minus 1 equals plus or minus 2 root 3. Let's just move this back a little bit so we have the space. Okay, so now we're going to add 1 to both sides. So x is equal to 1 plus 2 root 3, or x equals 1 minus 2 root 3. And that's the solution to that question. And then finally, example 3 here, going to solve this by completing the square. Okay, so first issue, let's deal with this. Now, I can't complete the square yet because I've got this 2 outside. So what I'm going to do is I'm going to factor out a 2 there. And we get x squared minus 2x, close the brackets. And then we have this 1 at the end. And that's equal to 0. Now what I'm going to do is I'm going to complete the square. I'll use green for this. I'm going to complete the square for this part. So let's leave the 2 outside for now. Open some brackets. We've got the plus 1 over here. Okay, completing the square for the green part. So opening brackets, we get x. This is negative, so I'm going to make that negative. Half this coefficient, we get 1. Close the brackets and square. When I expand this out, I'm going to get a positive 1 at the end, which I don't want. So let's take that away. Next stage, multiply this 2 into the bracket. And I almost forgot, it's still equal to 0. So multiply the 2 into the bracket, we get 2 times x minus 1 to be squared minus 2. And we have this plus 1. And that's equal to 0. Okay, let's start to work towards a solution now. So, 2 times x minus 1 all squared. Tidying this up, we get minus 1 equals 0. And let's continue on. 2 times x minus 1 to be squared must be equal to 1. So we added 1 to both sides. Now we're going to divide both sides by 2. And we get x minus 1 all squared equals a half. Then we're going to take the square root. The square root of a half is going to be plus or minus square root of a half, which is the same as plus or minus 1 over root 2. Now remember, the square root of a product is the same as the product of 2 square roots, so I'll just write that over this side. Root 1 over 2 is the same as root 1 over root 2, and the square root of 1 is 1. So just in case you were wondering where this has come from, that's what's happened. And then finally, adding 1 to both sides, we get x equals 1 plus 1 over root 2, or x equals 1 minus 1 over root 2. And that is how we complete the square. Now I'm going to leave you with one more thing before we finish up. I'm going to show you Desmos again, just to show you the power of completing the square. I won't take too long on this one. Let's go to one of the first examples. So this one here, when we completed the square, we had x plus 5 all squared plus 4. So let's put that into Desmos. X plus 5 all squared, x plus 5 all squared plus 4. We had y equals, let's just double check we had that right, x plus 5 all squared plus 4. Wonderful. Now, okay, now you can go into Desmos yourself and experiment and try and discover some more things about completing the square. Let's just make this a little bit bigger, but a couple of things you might notice. What completing the square does. You might notice that the minimum point is minus 5 and 4, and we can see that we have these numbers here. We have a 5 and we have a 4, so there is a connection. Maybe you can figure out what it is. It tells us the line of symmetry, and we can see that the line of symmetry is when x equals minus 5. If I make x equal to minus 5, everything in the brackets are going to disappear. When x is minus 5, this all becomes 0, and we end up with y equals 4. So we've got some really nice features that come out when we complete the square. Something maybe for you to try. I would suggest typing this into Desmos. Y equals a times x plus b all squared plus c. Let's put the equal sign in there. You can add some sliders. You get a general quadratic, and what you can do is you can change the value of a, you can change the value of b, and change the value of c, and c, maybe you can work out what these numbers actually do. But for now, that's all from me. Hopefully you found the video useful. We'll be back again with another one soon. All the best with the revision, and I'll talk to you again sometime.